Hello everyone and welcome. In this video, we're going to take a fast but detailed journey through the history of artificial intelligence. When people hear AI, they usually think of ChatGPT, robots, or futuristic sci-fi movies. But the truth is, the idea of artificial intelligence is much older than computers. It goes back thousands of years, back to myths, philosophy, and early mechanical inventions. In this video, we'll explore the biggest milestones in AI history, from ancient Greece to the invention of programmable machines, to Alan Turing to the birth of modern AI in the 1950s, all the way to deep learning and generative AI today. Let's start at the very beginning, ancient Greece. Before we go into the history, we should define what we mean by AI. Artificial intelligence is basically the attempt to create systems that can imitate human intelligence. That could mean reasoning, solving problems, learning from experience, recognizing patterns, or understanding language. What's important is that AI is not just one thing. It's a broad category ranging from basic automation all the way to systems that can generate text, images, music, and even code. Historically, AI was an idea long before it was ever a working technology. So the story of AI starts with imagination. The first major place we can trace AI concepts is ancient Greece. In Greek mythology, there's a famous story about Talus, a giant bronze automaton created to protect the island of Crete. Talus would patrol the island and attack intruders. In a way, Talus is like an early fictional security robot. There are also stories about the god Hephaestus, who supposedly built mechanical servants out of metal, basically ancient robot assistants. Obviously, these weren't real machines, but what matters is the mindset. Humans were already imagining artificial beings that could think, move, and act independently. So even in ancient times, the concept of artificial intelligence existed as a dream. Beyond myths, ancient Greece also gave AI something even more important: logic. Aristotle, one of the most influential philosophers in history, created systems of formal logic. He studied how reasoning works and developed rules for making correct arguments. This matters because logic is basically the foundation of computer science. Even though Aristotle didn't invent computers, his work created the idea that thinking could follow structured rules. In other words, he helped plant the seed that intelligence could be formalized and maybe even replicated. Centuries later, AI researchers would build entire systems based on logic, trying to make machines think using rule based reasoning. After Greece and Rome, the story of AI shifts from philosophy into engineering. During the Middle Ages and the Islamic Golden Age, inventors started building real mechanical devices that could mimic living things. One famous example is Al Jazari, a brilliant engineer from the 12th century. He designed water-powered machines and automated devices, including mechanical musicians that could play instruments. These machines weren't intelligent, but they showed that complex behavior could be built into a system. This period is important because it shows a transition. Humans stopped only imagining intelligent machines and started physically building machines that could simulate life. During the Renaissance, the obsession with under humans grew. Leonardo da Vinci, famous for art, also designed machines. One of his most interesting concepts was a mechanical knight, a human shaped automaton that could potentially move its arms and jaw. Again, it wasn't AI, but it shows that people were increasingly fascinated by the idea of building artificial humans. The Renaissance pushed scientific thinking forward, and as people learned more about biology and physics, they began to believe that maybe humans were also like machines, just more complex. That idea would later influence AI, the thought that intelligence could be engineered. Now we move into the early modern period where things start to get serious. In the 1600s, inventors like Blaise Pascal created mechanical calculators. Later, Gottfried Wilhelm Leibniz improved them. Leibniz is especially important because he imagined something revolutionary, a machine that could manipulate symbols and logic, not just numbers. He believed reasoning could be reduced to calculation and famously suggested that someday disagreements could be settled by saying, let's calculate. This is basically a philosophical preview of artificial intelligence. The 1800s brought a major turning point: programmability. The Jacquard loom used punch cards to control weaving patterns. This was one of the first examples of a machine being programmed using instructions. Then, Charles Babbage designed the analytical engine, a mechanical computer concept that could, in theory, perform many different tasks. Ada Lovelace, working with Babbage, wrote what is considered the first computer algorithm. She even predicted that machines might someday work with music and symbols, not just calculations. This is huge because AI requires computers and computers require programmability. The foundation was being built. As we enter the early 1900s, mathematics become deeply connected with logic. George Boole created Boolean algebra, a system where everything is reduced to true or false. That might sound simple, but it's the basis of how modern computers work. Other thinkers like Frederick Russell and Hilbert worked on formal systems, ways to represent knowledge using symbols and rules. This period matters because it strengthens a key AI idea. Maybe human thinking can be represented mathematically. If thoughts can be represented as symbols, then a machine might be able to manipulate those symbols and therefore think. Now we reach one of the most important people in the entire story, Alan Turing. In 1936, Turing proposed the concept of a Turing machine, a theoretical model of computation. This model proved that a machine could follow instructions to perform any computable task. During World War II, Turing worked at Bletchley Park, helping break the German Enigma code. This showed how powerful computation could be in real life. In 1950, Turing published a famous paper asking, "Can machines think?" He proposed the Turing test. If a machine can hold a conversation and fool a human into thinking it's human, then it can be considered intelligent. This was basically the first major benchmark for AI. The official birth of AI as a scientific field happened in 1956. At the Dartmouth Conference, researchers gathered to explore how machines could simulate intelligence. This is where the term artificial intelligence was officially coined. The researchers were extremely optimistic. Some believed that within a few decades, machines could be as intelligent as humans. In hindsight, they underestimated how complex human intelligence really is, but this event marks the start of AI as a real research discipline. The first major wave of AI is what we now call symbolic AI. Symbolic AI is based on rules and logic. The idea was that intelligence could be created by programming explicit knowledge into a machine. Early AI programs could solve algebra problems, prove geometry theorems, and play games like checkers. This created huge excitement. It looked like the dream of intelligent machines was finally becoming real. But symbolic AI had a major weakness. It worked well in controlled environments, but struggled with the messy complexity of the real world. In the 1960s and 70s, researchers started building robots and early chatbots. One major project was Shaky the Robot, one of the first robots able to navigate an environment and make decisions based on logic. Another famous program was ELISA, a chatbot created in the 1960s. It simulated a therapist by rephrasing user inputs. Even though ELISA was not truly intelligent, people were surprised by how human it felt. This shows something important. Humans are quick to assign intelligence to machine, even when the machines are just following patterns. After early excitement, AI ran into reality. Researchers had promised big breakthroughs, but computers were too weak, data was limited, and the problems were harder than expected. Governments and investors started cutting funding. This period is called the AI winter. It happened more than once, including major slowdowns in the 70s and again in the late 80s. AI winter is important because it reminds us that AI development is not a straight line. It moves in cycles of hype, disappointment, and new breakthroughs. In the 1980s, AI made a comeback through expert systems. Expert systems were programs that capture human expert knowledge as rules. For example, in medicine, an expert system might help diagnose diseases based on symptoms. These systems were actually useful and many companies adopted them. But they had a problem. They were difficult to maintain and they couldn't easily adapt or learn. If the world changed, the rules had to be rewritten manually. So expert systems were powerful but not flexible. A major milestone came in 1997. IBM's Deep Blue defeated Garry Kasparov, the world chess champion. This was huge news. It felt like a sci-fi moment becoming real. However, Deep Blue wasn't thinking like a human. It relied on brute force computation and chess evaluation strategies. The world learned an important lesson. Even without human-like understanding, machines can outperform humans in specific, narrow tasks. By the year 2000, AI began shifting away from hand-coded rules. Instead of telling computers exactly what to do, researchers started training systems on data, allowing them to learn patterns automatically. This is machine learning. The rise of the internet created massive data sets, and computers became much faster and cheaper. This created the perfect environment for AI to evolve. Instead of logic-based reasoning, AI started becoming statistical and data-driven. One of the biggest turning points in modern AI happened in 2012. A deep learning model called AlexNet dramatically improved image recognition accuracy. This was possible because of powerful GPUs and large datasets. Deep learning is based on neural networks inspired loosely by the human brain. Unlike traditional machine learning, deep learning can automatically learn complex features from raw data, like pixels in images or sounds in speech. This moment kicked off the modern AI explosion. In 2016, another major AI milestone happened. Google DeepMind created AlphaGo, an AI system that defeated Lee Sedol, one of the greatest Go players in history. Go is far more complex than chess, with more possible moves than atoms in the universe. Many experts thought it would take decades for AI to master Go. AlphaGo proved them wrong. This moment showed that AI could handle creativity, strategy, and intuition like decision making. Now we arrive at the AI era we live in today, generative AI. Instead of only recognizing patterns, AI can now generate new content, writing essays, making images, producing music, and coding. This is powered by large language models trained on massive amounts of text from the internet. Tools like ChatGPT made AI accessible to the public. Suddenly, AI wasn't just a research topic, it became part of everyday life, used by students, businesses, and creators. This is one of the fastest technology adoptions in human history. As AI becomes more powerful, new concerns appear. One big issue is bias. AI systems can reflect the biases in their training data. Another issue is misinformation. Generative AI can produce fake news, fake images, deepfake videos. There's also the economic impact. AI is changing jobs in writing, design, customer service, and even programming. Finally, there are privacy concerns. AI systems depend on huge amounts of data, and people worry about how that data is collected and used. This is why modern AI development includes not just innovation, but also ethics and governance. To wrap everything up, AI is not just a modern invention. It's a story that started thousands of years ago when people imagined artificial beings like Talos in ancient Greece. Over time, philosophy gave us logic, engineering gave us machines, mathematics gave us computation, and computer science gave us modern AI. And today, we're living in a period where AI is not just an experiment, it's real, powerful, and shaping society. The big takeaway is this: AI is not a sudden revolution. It's the result of centuries of human curiosity about one question: can we build intelligence? And the truth is, we're still figuring it out. Thank you for watching.